Hello, everybody. So, got a couple things to go over tonight. Still sort of just basic syntax. Look at selection structures and loops. Oh, yeah. Yeah, it's a long drive for me. The comment in the chat room, right before the recording started, we were talking the Tech Club is having a Smash Brothers tournament tomorrow on campus. I was getting ready to send the information, so probably a good time to send that link. I'll send it out. I'll stick it in an announcement. That way everybody can see it. Because I know two of the people in our class work on Thursday nights. That funny little technicality from Amazon. They'll pay for your school, but they won't let you off to go to class. That always seems very odd to me. But a lot of people work at the Amazon distribution center, so it's a fairly common thing to see. So I'll put that in an announcement. So I have a link here. Actually, I have to copy the link from the announcement in the previous class, or this afternoon's class. Yeah, the School of IT here at Sellersburg has a tech club, technology-oriented club, focusing on computer stuff. You may often hear me refer to it as the computer club because there used to be a computer club, but that kind of fizzled out during the pandemic when clubs couldn't do anything. And when we came back, the new people, they wanted a new name for it and stuff. So they wanted to expand beyond solely computers and just technology to get into Internet of Things and the stuff that aren't these machines explicitly. So they want the technology instead of computers explicitly. It seems to still include it, but allow for more stuff to work in there. But one thing they often do is have annual events. School of IT. So on Friday, Tech Club is hosting a Smash Brothers tournament. If I can spell things correctly, on campus. Here's the info. So there's a link with to the announcement in Ivy Life that will show you the times. It's noon to 6 tomorrow in Powell Hall, room P5. That's right next to the Ivy Life room. Kind of club oriented hangout spot where there's pool tables and all those other games and stuff. Right next to that is a big empty room kept open for club purposes. So they're gonna have a Smash Bros. Tournament in that empty room. So just right over in the building up front. It should be a fun event. It's a fun game, so it's a good one to a good way to relax. As far as us tonight, back to Java stuff. So we finish looking at some of our basic syntax, our basic tools, the selection structures and loops, the syntax for those. And we'll probably go ahead and bump up and start looking at some of the module 2 stuff. So for those who haven't had me in class before, I try to teach more than I test you on. Just things that I think will be useful. We'll talk about them in class, but usually it's stuff beyond the homework. So part of that is I like to get a little bit ahead of where the homework assignments are in the lectures. And that way when we get to the end and I know what some of y'all's interests are in particular, I have a big list of odds and ends to shove in. We're very restricted on time in a classroom, so we can't fit everything about Java. So there at the end, I have a big list of odds and ends, and I know a little bit better what some of y'all's interests in particular are. I'll know which ones to cover there. So I like to try to get a little bit ahead on the lectures if we can. So we'll probably get started into arrays and methods tonight as well. Just know some of our basic structures. You would have seen those in the 2 prerequisites for this class. And SDEV 120 and SDEV 140, talk about those. So really, we just need the Java syntax for them. We have actual arrays in Java. So in the previous two classes, we would have been working with languages that don't actually have arrays because of that technicality. So it's slightly different than working with lists. Arrays are non-dynamic, but there's also a really nice structure in Java that most people use in place of array. And that's our catch-all term, kind of like how we say Google stuff when we go to look it up, because if we use the other terms, like list especially, that's the one we use the most often. But list also means something in normal English. And what it means in normal English is not at all the same as what it means in the computer. Array is sort of our catch-all term. So we'll probably get to that. But first off, we started looking the other day at the primitive data types. Data types are integers, floating point numbers, booleans, and characters. That's our basic data types. The simple data that we that can cover everything, but we probably want something more complex. So we'll combine those primitive data types into our own custom data types very, very shortly, which actually we already have. And when we get to methods, it'll be the first time we really see it, because everything in Java is object-oriented. That's why one of the first keywords we have to put in every Java file is it's a class. We're only making objects. Just so happens that the main is a special one because we have to run that before we instantiate any objects. So our main has to be static so that we can look at the definition, the blueprint for how to make the object. Because we won't have an actual object when we first start our program. So we looked at some primitive types the other day, and we'll combine those up. The numbers, we can do math with those. We can tell if things are true or false, but that's a big one. We probably want to be able to do things when we know if something is true or false. And basically make choices, all right? With what we've seen so far, use black marker. I think I forgot to ask, is anybody colorblind? Should I throw some of the markers away? I see head shaking no. Okay. I always like to make sure, I hope that's not personal information, but if there's colors people can't see, I definitely don't want to be using them in the notes. And I've heard the people that can't see blue, I might as well be using white on a whiteboard if I use a blue marker. So I try to check, but with what we saw the other day, we'd have a flow chart that kind of looks like this. We want to do a little bit better in our program. Sometimes that's what they do, right? Our program starts and it runs and then finishes. But usually we want to do something a little bit more interesting. So we need a flow chart that can come down and make some sort of decision. Check conditions, check with the National Weather Service to see what the chance of rain is, and have our phone beep a notification when we get to approach the door to tell us whether or not we need an umbrella or a jacket or something like that. Some sort of selection so that we get more interesting flow charts going on. And more interesting things happening as the program flows. So that's the first thing we want to look at is our selection structure, ways to make choices. One of our key tools. Taking a term for it is the four constructs. Goes beyond any computer science subsets of it is problem solving itself. There are only four types of tools we need to solve any problem. A sequence, an order for things to go in, some sort of selection structure, next one we're going to look at. So a way to make choices as we go through that sequence. Might need reiteration, ways to repeat steps if they're necessary. And we also need what's usually called invocation. We need a way to step out of our sequence and come back to the spot we left. And those four types of tools are all we need to solve any problem. It's like the famous one, the solution to world peace is only going to use those four types of tools. It's just nobody's figured out the right order to put it in or the right choices to make along the way. But those we'll solve any problem. And as software developers, that's what we're trying to do, solve problems. So let's take a look at selection structures. This will be the next thing to look at here. So I'm creating a new Java project. I always click the little icon there. Under file menus, a new project, more than just one single file. We want to spread things out and have lots of files and big pieces of software. There's going to be a lot of automated files too. So the computer will write all those for us. And for class, at least starting out with, we're just going to use Ant project. The Ant project management packaging solution, I think is the technical term for it. We call it solution now. It might not have been called solution whenever Ant was made. I think they had a different name back then, but nowadays we call them project package management solutions. And just a regular Java application. And on your homework, like I pointed out the other day, go down to Java Web and create a web application and do some JSP pages, and we'll see servlets before too long. That's what you're going to do a lot more of in the modern world. But it will take the same logic. We put the same logic there as we do in a main method. So I'm just going to do a main method for tonight's example. That way there's not a bunch of HTML cluttering up the screen. So where is it going to be saved? That looks good. Yeah, this option, you can just leave that unchecked, the dedicated folder for storing libraries. Most of the libraries we're using, all of them at this point are already in the same spot where we install Java. That's where we import our libraries from. But before long, we'll bring in some that aren't part of that official install, and we might need a place to put those. And even when we do that, I'm just going to go through the steps of making a folder where I know where it's at, put it there. So might not necessarily need the IDE to do that for us. And if you don't create the main class, you have to create a main class before you run it. I'll leave that unchecked for now. Usually we want to check that box, but I'll just leave it unchecked for this example. So the first thing you'll notice is it didn't automatically open a Java file. We didn't create the main class. So we have to make our starting main class. I think this is the one I just created. So under source packages, there's this default package, but usually we don't want to use the default package. And where that is if we go over to the project, we haven't really looked at these much yet. Oops, not downloads. In documents and NetBeans projects, here's that latest one. And there's build instructions, like how to put all this stuff together. And then the source folder. So if you just say the default package, it puts it right there in the source folder. As software gets big, that's still even going to be a little bit disorganized. So usually we want to put another folder inside of that. And when we say package, that's kind of referring to a folder. A package that holds all of our categorizes and organizes our Java source code, but really that means a folder. So come up here on projects and right click and create a new one. So we have a new button, but the thing is, if you just click the new button, like it doesn't know where to put it. So it's much better to right click on your project. And this is not just NetBeans. Most of your good IDEs want to do it that way. Right click on the project and use the new button here, because then it'll put it in the right spot. So we need a Java class. I don't know, I'll call it choices. And notice how this is still blank. It doesn't, down here, the third box down for package. Like I just said, that's kind of what folder we put it in, but there's some background stuff going on as well that the word package extends beyond simply being a folder. But at least for starting off here, think of it as that's the folder we're going to put it in to keep everything organized. And we always want to do that And the naming convention is all lowercase letters, shove words together, get together if needed, but all lowercase letter for the package, because when we import stuff, we import the package. Before we import it, we have to take that folder and turn it into a jar folder, which is the equivalent of an executable file. For the classroom, might as well go through the steps now. And if you haven't seen it before, an executable file, the .exe, that's actually a zip folder. It's a zip folder that only contains stuff the computer knows what to do with. Maybe binary code, maybe assembly language, maybe bytecode, but it's all stuff that the computer can run zipped up in a folder, so that humans don't really have access to unzip that folder because there's nothing there in human format. Java has an equivalent called a jar file, and those are what, so we want to zip up our folders into that. I'll give this the same name. I'll call it choices. I can't think of another name quick enough. I'll go ahead and finish this. Oops. I'm gonna get all this stuff out of the way. I meant to point at that already. I'm gonna take a quick sidestep. If you go to tools and options, tools and templates. Here's where you can get to those generic text files, those starting points. Because usually we know certain things are going to be in every starting point, right? We don't need to start with a blank file every time. So you can go in here and edit these files, and then that sets up your starting point. I meant to point that out last week and kept forgetting to. So things like getting all those comments out of the way so that we can, we have a nice clear space to work with. But like all this stuff we know is going to be in there. And notice that choices is our folder name. You can kind of see it over here, but I still have this open. So in our source folder, or the SRC, there's now a folder called choices, and that's where that Java file went, which we'll refer to as a package. And the first line here, it doesn't have to be line number 1, but it does have to be the first line. So if you want some white space up at the top, that's fine. But the very first thing has to be what package it's part of. Because things in the same package know about each other. Any file we put, any Java file we put in that choices folder now will know about this Java file. But anything in another folder would not know about it. So we have to organize it and say, kind of say which folder that belongs to. Now I'll go ahead and do this. So before I start typing, we have some code here. Right? In the prereqs for this course, you would have seen Python. And in Python, you type in a little bit of stuff and hit run, and it's going to do something. But even if there's not a print statement there, it's not going to crash when we hit run. This will. It can't run it. It doesn't know what the main file is. It's like, okay, we can run, but where do we start at? So we're lacking that main method, which go over that one more time. We need it to be accessible. Other software needs to access it, in particular the operating system or the Java virtual machine needs access to it. So this needs to be public. This is the very first thing. We haven't had a chance to instantiate any of our objects. We haven't had a chance to say a choices C equals new choices and create an instance of our object, which we'll cover that soon. So we can't refer to an instance of the object. We have to refer back to our design for the object itself. So it needs to be static, which means there's one and only one copy. Sometimes it's useful for the one and only one, because things we don't need hundreds of copies of. Like one copy will be fine for everything. Like if we wanted a counter that counted if we made an employee object and wanted to quickly know how many employee objects have been instantiated, we can put a static counter in there, because then there's only one counter for all of the objects we create. So they share that, they'll all share that counter. So sometimes it's useful for that. It's also also critical for when we need to do things right at the beginning with our starting point. We're not going to return anything. It's a strictly typed language. We have to be explicit about everything, every data type that we're using, every place we would have a data type. And we're going to call it main. And since we're going to usually click on buttons, but anytime we click with our mouse, that's actually calling command prompt or terminal or shell instructions in the background, right? If I come over here and click on the icon for Google Chrome, what that's doing is telling PowerShell to run the command start item chrome.exe. So it's always running those shell commands. So whenever those run, there are other parameters that we can pass in. Parameters, arguments. We set things up to accept parameters, and then we send arguments to fill those parameters. Some important terminology there that will definitely show up on pretty much every certification exam you take for a language. Your method will accept parameters, and then when you call it, you send arguments to fill those parameters. But we need to leave a spot for that. So our spot will be an array of strings, and traditionally it's just called args. The reference value could be whatever, but if you put anything other than args, people would look at you and be like, why'd you call it that? That's the only word there's any option for in that. But that's what our main method always needs to look like. And well, there's already 2 closing curly braces down here, and we haven't done anything yet. It's really easy to get lost in closing curly braces. So it's a good idea to label those. So I'll put a little comment and say in main, something to tell that what that curly brace goes with. The opening curly brace is easy. Oh, and those are completely your choice where you want to put them. We could do it as one long line, do an open curly brace, do a whole bunch of instructions, then a closing curly brace. We can put it down here on the next line. White space is deleted before we compile it. That's only for our benefit. I usually go with this one. And this was just a straight survey. They went ahead and asked thousands of programmers, what's the easiest way to read curly braces? And the majority said something like the method header, the description, we're gonna get to the technical term later, but the description of the method, the header, or whatever we're doing, those opening keywords. And on the same line, put the opening curly brace, a few lines later, line the curly brace back up with those words and indent everything in between. That is just a pure majority. That's what most of the people answered on that survey was the easiest to read when they asked a bunch of programmers, when they asked thousands of programmers. But any way you want to do it is fine. If you think it's easier to read with your opening curly brace on the second line, that will be fine. There's no, as far as your homework assignments and stuff, do whatever you think is easiest, whatever works most for you. I have read lots and lots and lots of code over the years. So for examples, I just go with that one that the majority says is easiest to read. So now I'll just put a quick check to make sure everything's working, and then we'll get into our stuff. In NetBeans, if you type S out and then hit tab, you should get all of that. Other IDEs have similar things. Some of them you might need a capital S. I think in VS Code, you have to type S out in all caps. And then when you hit tab, it'll do all that. I don't use VS Code very often. Actually, almost never. Other things built on that same framework as VS Code are, you have to do it in all caps. So that should give us a check. If we come over here and run it, we're still getting that message says it doesn't know what to do. But it kind of indicates there's one option on that list, right? It doesn't know has to know which class has the main method. Because Java is a compiled language. It can't, or another better way to say it, it's a machine. Machines aren't intelligent. It can't figure out which main method to use. We only have one, but when we're putting something big together and testing and debugging, we might put lots of main methods in there. That way we can test small sections, right? So we have to tell it explicitly which class to actually run from. And before I hit OK, I'm gonna come over here and look at the properties here, just to show you where this is in case you ever have to change it. Under run, right click on your project and go to properties. Under the run menu, there's an option for main class. So if you ever have to change it, like if you didn't click it, if you click that checkbox there at the beginning to create the main class, and then you delete that one and make your own. So it's looking at the wrong thing. You come over here and then that browse button pulls up that menu where he pulls up that list where you can search for the one you want. And so that is the main class. Or if you know what it's called, which you will if you're the developer, you can just type it in. Might be quick. If it's several folders deep, it's probably quicker to just type it in. But we do have to be explicit about which thing holds our main class. Hit OK. Now when we run it, oh, you already see that message box isn't popping up. So the standard test checked out. Hello world printed the screen, so everything's should be configured, ready to go. We've seen all that stuff before. And we quickly covered math. Did anybody want to go over math in more detail? We kind of rushed through some of that at the end. It's the operations you're probably used to. The one thing, if you divide two integers, the result is an integer. It's not a floating point number. One of the numbers has to be floating point, so you do need to cast one of them or have at least a floating point number in that division somewhere if you want a floating point answer. Otherwise, you get the integer division where it just truncates the rest of it, expecting you to do integer division and modulus, so we have quotient and remainder instead of a floating point value. That's the big thing on the math. Otherwise, it's the same symbols. So yeah, I guess another way to say it, since everybody who saw Python in the 2 prerequisite classes, your default division, it's always 1 slash in Java, but the default is going to be like 2 slashes in Python, the integer division. So we might want to check some things, right? I haven't looked at input in a minute, so I'm going to set up some input. Does anybody remember what we need in order to get input?
Scanner?
Yeah. So we'll need a scanner type of data. And when you look at textbooks and tutorials and examples, they're almost always going to call it input. But scanners always get input. So I like to be a little bit more explicit. And in this case, we're going to be getting input from the keyboard. There's a new scanner. And just like when we send things to our console, that's our system standard output. The keyboard is our standard input. So system.in will be the keyboard. And then we need to import that. So we come up here and type import the Java package or java.util package, and then get the scanner out of it, or just the wildcard, or in NetBeans, Control-Shift-I will automatically import. Whichever way you want to do it, they all kind of work out the same. And the wildcard selector does not mean when you compile. An import is a copy and paste. So if you have not seen that before, when we go to compile this, it's gonna go over to the java.util folder, grab something. If we type scanner there specifically, it's obvious what it would grab. And then it's gonna copy that and paste it right there in our code for the compiled version. So I believe it's already been mentioned. Keep in mind that what we type is not the same as what runs. Right? We type in a sort of high level language human form, but the computer is going to run bytecode. So, and that's different. So it will actually copy and paste stuff. And it's not going to copy and paste everything in that library. The compiler is going to look ahead and see what we need from there and only grab the things we need. The default optimization, that kind of had to be on the odds and ends list in this class, but we can modify our compiler slightly. I don't know if we'll see that on our odds and ends. There's probably things that will be more useful for you because we pretty much never do that. The Java compiler is optimized for RAM efficiency, which might not be the fastest. So maybe you want to re-optimize for speed, or you want to re-optimize for communication with the network protocols. So we can modify that, but I don't think we'll get to it in the class. So usually if we opt the default of optimizing for RAM efficiency, works really, really well. So we usually go with that. So now we have a way to get input. So I'm going to send out a prompt, say S out, and because of the way I like to have my input on that same line, so I'm going to delete that LN. So system.out.print is no line beat instead of print line. And we'll go here. Give me a number. Give me a number. And then we'll set a place for it. I don't really know what the user's going to give us. So you can type, we said give me a number, they're going to type in an integer, or a floating point number. I'm going to start with integers. And we'll be specific. Give me a whole number. And then we know we should be getting an integer from the user. So what's going to come back is going to be integer data. So the type of data we have, user number is that scanner object, the particular instance of a scanner object we created. And if we start typing next, you'll see there's not just the basic next, there is an option for specifically the things we're looking for on those primitive data types, the next byte, the next integer, the next short. I'm gonna, in a lot of cases, we can use next, just use next would be fine. But that kind of falls back on trusting our user to give us a number when, just because we said give us a number. It's a lot of faith to put in a user, right? So I'll explicitly say next int. That's usually a good option. Because if we don't say next, if we just say next, we do have to cast it. I'm gonna come back and change it and do the other. I'll put a couple options in here. And then we can make some choices with that. I guess let's, a simple case here, because you all know what to do with selection structures, right? Everybody saw those in previous classes. So we just need the syntax. So our keyword is if, one you're probably familiar with. When we're putting algorithms together, we want to think is, so we're asking the question like, is this big, is user number smaller than 5? But we're not asking the computer, we're telling the computer. Is user number less than 5? So that part probably looks like what you've seen before. And if there's only one line, this is probably the only time I'm going to do this semester, because before I even run this, I'm going to come back and not do the one line thing. That's a small number. That seems like a good trivial example. Somebody tell me what I left off there.
The semicolon,
Oh, there's a semicolon.
the on that line 13.
Oh, yes. Can I make that bigger? Where's my font size? Fonts. 18. Okay. And then close all this up. Can you see that a little bit better? Let that open and close it. We're right here. Oops. I don't know why that's keeps popping back open. I got. Yes. And if a selection is a block, right? If that's true, we're going to run a bunch of instructions. If there's only one, we can leave the semicolon. We can leave the curly braces off. Almost said the wrong thing. If there's only one line in that block, we can leave the curly braces off because it's obvious what goes there. But I would highly, highly, highly recommend never doing that. Because there's a good chance you're going to come back and do some editing and stuff, right? Your programs are going to, your software is going to grow. So if you leave them off because there's only one line, it's really, really easy to forget them when you come back and put a second line in that block. So I'm going to highly, highly recommend not using that function just because it's available. If I would have, yeah, when you type the opening curly brace, the closing curly brace will automatically type. I had to type them around that way, but I would definitely recommend always use your curly brace. Don't even worry about that rule because when you come back and edit and modify your code, it is really, really easy to forget that you left the curly braces off. Forget to put them in. So again, we're blocking off as to block off a set of instructions, we use our curly braces. It's just that way we can get it around at one time. So that should run now. Let's give it a run and see what happens. So asking for a whole number. Here is a whole number. 5. So that's kind of the thing I was talking about earlier, right? We would have just said next. The computer would have grabbed the word here. And the actual number is way down there. Still threw it off though, right? And we got a little traceback error. This is kind of what the tracebacks look like in Java. They can get really, really, really long at times. So where did things go wrong? So scanner object, scanner object, scanner object. Oh, here's something with our code. And line 10, it couldn't find an integer because the next thing is the word. So it doesn't, it's not going to skip ahead. It's not going to jump ahead and find and just find the integer because there's one further down the line. It's going to grab the next hint. It's going to grab the next thing and try to automatically cast the next thing. So that's not a search. That's not a search next. Does that make sense? It is actually looking for the next thing. So if I just type 5, let me run that again. I was comparing it against 5. So a number smaller than 5 is the only thing that's going to do something right now, isn't it? So if I just type 3, it's going to run that condition. So it's not a search. A lot of people expect that because we're used to fancy finished software, right? We just have our fundamental tools here. We're building that stuff. Another alternative, I'll comment that line out and say int user number is keyboard.next. I'll just go with the regular next one. come back and spell keyboard correctly. And you'll notice that the compiler already spotted a problem with it. Oh, error messages come from the compiler. I haven't said that yet. That underlining when it doesn't recognize something. In an IDE, our compiler is constantly running. So it tried to compile it and it's like, oh, there's a problem here. So if y'all remember back to that, I guess first day when we were doing stuff in the text, just regular text editor in the terminal, when we tried to compile it, we get messages saying, well, we're wrong. And that's the message we get with an underline. So that stuff does come from the compiler. That's why we don't have to explicitly compile it, because it constantly compiles along the way. Well, it's coming from a keyboard, so that's a string. We said just grab the next thing and told the computer it's going to be an integer data. So we might need to cast it. Which just normal casting didn't seem to work, right? It's still underlined. This, again, a string cannot be converted to an int. So nothing's different there. What we have to do is, int is primitive data, but I've already repeated the phrase a number of times in our class that everything in Java is object-oriented, right? Primitive data is not object-oriented. So that's just, the primitive data is carried over from C++. So we need an object version of an integer that has methods built in, and we have one. So integer with a capital I, and notice the predictive text brought up a whole bunch of things. Get integer from a string, hash the integer. We want this one, parse the integer from a string. Because parse integer will protect a little bit from that other stuff. That thing we were just looking at where I had a bunch of words, then a number, that would fail on every time on get integer. So we're going to do integer dot parse int on that thing coming from the keyboard. Try to get the Zoom thumbnails out of the way over on that machine. The one showing on the big monitors in the glass. Although I think both of y'all have it on your there beside you, don't you?
Yeah.
Okay. Yeah, so those won't really affect anything. So you probably have Zoom thumbnails in the way over there too, don't you?
I guess a little tiny one.
Oh yeah. Yeah, that's usually a good idea. Keeps them out of the way a little bit better. Let's see. So the parse int, and notice the capital I, it's written in Pascal case indicating that it's an integer. It's also a static integer. I was talking about static earlier. If there's one and only one copy, we grab stuff from the blueprint, the design, the file that says public class integer. We don't have to say this is going to be a new integer and then use that to call the method. Static things we call directly. So we put class name dot parse int. That's our other main use for static. We don't need a particular integer when we're going to do the same. We're going to treat all of our integers the same, and we don't want to create an instance for every possible integer. So we just use the same one. Now when we run it, ask for a whole number, say 5. Oh, sorry. We only have the one condition so far, let me enter 3. So that it does something. Yeah, so if with the blocks, and then it does something or it does nothing right now. Run that again. Here is a number. 3. Any thoughts on what's going to happen when I hit enter? Crash, run. Wait and see. I see some hesitation in the classroom. I'm good. Guessing it's probably the same thing on the on Zoom call. Let's wait and see. That's debugging, right? Will this work? That's when we learn things. Take a guess. Take a guess, see if it works. If it doesn't, try something different. Always do that first. Never run straight to the Google and look up what you're doing. Give it a try first. I usually say 3 times. I'll take like 3 guesses, and if none of those work, then look it up. Because, well, for one, that's going to make you a better programmer. Because you're not just you're learning something other than just how to look it up. And you don't want to waste all day taking guesses. So I'd say 3 is probably a good number. Take a couple guesses, and if you can't figure it out from what you know about the language in 3 guesses, then go look it up and learn more about the language. So yeah, for questions like that, the correct answer is probably run it and see what happens. Oh, we still get that error message because we say grab the next thing. Keyboard.next. Change that to next line. We'll see if that works a little bit better. A good number might be 3. So there's an integer in that line. Well, it still wants the next, it still doesn't quite know where to look for it. So we do have to be particular on what we're grabbing. There's not, we'll have to get into, when we get to this, talking about strings specifically, we'd have to use the string search feature to dig through and find and then it's a particular integer. A lot of people think we might have to be able to do that, but we're pretty much just grabbing the next thing any way we do it. And that next end is equivalent to this. We'll get the next integer in Parse Hint. So we know if we type 3, says it's a small number, but 7, otherwise we don't get anything. So our next block, well, you don't know how that works. If and else are obvious keywords. Sys that's a big number. But we probably want something in between them. Which the 2 prerequisites for this class use Python these days. And in Python, white space matters. So we can't have a 2-word keyword. So we combine that and shortened it. But in Java, we can have 2 words for our keywords. So we actually spell out else if. And then throw in a condition. Yeah, so in the prerequisites, you would have seen that with no white space allowed, but we're allowed white space in our keywords here, so we can have multiple words for a keyword. That's not the right way to phrase that, but I think y'all know what I mean. That was just bad grammar, but I think the point was still in that sentence somewhere. And have a 2-part keyword. That might be a better way to say it. Then we need another condition. User number less than 5, if user number is exactly equal to 7, as out, that's a 7. So we have multiple things going on. Can't change our mind at them suddenly there. I was going to put small, medium, and large, but looking at an equality. Because with integers, we definitely know when they're equal. I mentioned the other day that our decimal values, the things we're used to working with, just because it works out nicely in base 10 does not mean it's going to work out nicely in base 2. 1.07 is a good example. $1.07, which is what sales tax for $1 would be in Indiana, right? That does not come out evenly in base 2 with 64 bits. So we have 64 bits all for the fractional part. We still can't do 0.07. We're still a little bit shy of it when we run out of bits. So with floating point numbers, you don't want to check exact equality because that'll throw you off. But equal is our sign for direct comparison. There's a little addendum that'll make a much bigger difference. So let's check a few things. So enter a 3, get a small number, enter a 9, the big number, or a 7 for that exact quality. Exact equality checks for the same spot in memory. Java has really, really, really good memory management. In C++, we have to manually take control of that. We have to delete things when we're done, and we can control where it goes and stuff. But Java, they have put together really, really, really excellent memory management. So if we stored, maybe we had x equals 7, and then somewhere later in our code, we had y equals 7. Well, our memory management is going to notice that those are the same value and stick them in the same spot in memory. I draw a picture to help visualize that. And for those who haven't seen me in class before, show the pictures I'm probably going to draw most often to describe these things. And that's going to be a stack heap diagram. Stacks are what computers do naturally. So that's what most things fall on. And this is going to be our code. So we stack up our instructions, and then we pull the instructions off and run them one at a time. And a heap is a data structure. We will see that later this semester. We'll talk about data structures later this semester. Probably won't code up a heap like we will some of the simpler ones because it's kind of complicated. But for those who have seen it before, it has a big O of 1. It's our most efficient data structure for usage and organization, which means it doesn't matter if we have 3 things or 3 million things. It's going to take the same amount of time to retrieve them from memory. We don't lose efficiency as we get more data. So that's why RAM is usually managed from a heap. Because we don't lose any efficiency as we get more and more data. We still keep all our speed. I might have said that wrong. Obviously it's not going to be the same amount of time, but there's not extra time. So for some things, if we had 3 things in a stack versus 30 things in a stack, there's a little bit extra time. So it's not going to be 10 times longer. There's a little bit extra time for the bigger stack. Obviously, 3 things versus 30 things, it's going to take more time because we have more stuff, but there's not extra. So if we have 3 things or 30 things, 30 things would take exactly 10 times as long as the 3 things. We don't end up with anything extra because there's more stuff. I think I said that wrong, which obviously it's not going to take the same amount of time to go through more data. Or it will take more time to go through more data, but there's not an extra bit on there. So that's how we're going to organize RAM. And Java has really, really excellent memory management and garbage collection. We almost never mess with it unless something goes wrong. It can be difficult when something does go wrong. It will sometimes. One problem I've seen before is garbage collection not recognizing when it's finished with something. I've seen that happen on a server, sockets on a server. And sockets are how users connect to the server. So it will, if it's a very popular server for people to connect to, we will definitely run out of RAM if we don't clear out our data when we're done. But if somehow your code's set up so the garbage collection can't tell that it's finished with that, it's just going to keep it there in case it needs it again. But maybe we have a string here. So we have this variable pointing over at some string holding hello world. And then later in our code, we make another variable that also stores the value hello world. it's not gonna make two of them. It's gonna look at the data that's available and say, oh, that's already stored. So I can just point at the one that's already stored. So when we say equal, two equal signs, that refers to the same spot in memory. So if we don't want that, we'll have to change it, but we will see that very, very soon. It's actually something we often do, but most of the time that's going to work, especially for integers. Strings, it gets a bit more problem. Strings, we definitely want to override, but with integers, we want to make sure we're pointing at the same spot in memory. And then and then for fractional numbers, you want to kind of avoid the exact equality if at all possible, because we have that slight discrepancy at the end. So that's our basic selection structure, the if, and then we can keep adding up else ifs. Those should look familiar. We also have switch cases, which in Java, a switch case will be faster. Sometimes what we want to know, we'll have a bunch of if, else if, else if, else if, we'll have a whole bunch of different things. And we'll be checking exact equality every time. I'm going to type something, and then I'm going to erase it so you can just watch what I type, and then when I erase this, for those following along. So maybe we're checking what number we want to know exactly what letter the user gave us, maybe a grade thing. So if grade is exactly equal to an A, we'll do some stuff. Else if grade is exactly equal to a B, we'll do some different stuff. Else if grade is exactly equal to a C, we'll do some different stuff, and I think y'all see where that's going. There's not anything in between those grades. Some schools have the A plus, A minus. Here at our school, we do the whole grade, and there's nothing in between an A or B. It's a solid line there for one or the other. So it's very, very common that we're going to check exact equality. And when we do that, there's another structure we can use that is actually faster than a if else block. And that'll be a switch case. Oops. Not where I thought the cursor was. I'll set up a spot for it. So we'll get some character data, call it grade is, well, I'll have to ask the keyboard for it again. Keyboard.next. And it really won't next chart. Oh, there's not a next chart. Next will work, I think. And we'll enter a grade. There we go. Oh, I'm gonna take the line break off just because I like to put the input on the same line as the prompt. That's just a personal preference. Oh, no, string cannot be converted to char. A string, which is an array of characters, that reserved a bunch of space in memory, right? Because we need to fit a whole lot of characters, but our grade is one character, and we can't squeeze down. We could have a one character and shove it into a string with no problem, because then there's just a bunch of empty space. But we can't squeeze down because we can fill empty space easily. So it's sort of the same thing. We have an object version, character dot. Actually, we might be able to just cast this as a character. Is that gonna go in here? String cannot be converted to character. Nope. Character dot. Notice none of these look like a character, right? None of the options take in a string. Let's see, keyboard.next will be a string. Let's see what we have here. We get dot. Character at. That sounds like it might be a useful one. We can see our return type over here on the right from predictor text is going to return a character. That's what we need. Chars for a whole bunch of characters. Bunch of other things, but char at sounds like the one we need, right? We say enter a grade, and we know they're going to type one letter, and that's a string is an array of characters. So we haven't talked about that yet, but I know everybody's seen arrays before. So we know index 0 is going to be the one character they type in. So if we're grabbing it from our scanner, keyboard.next, and then we'll grab the character at index 0. So notice there's a couple different ones, but I guess the important thing in that little segment is it makes sense how to dig through that predictive text and figure out which one you need, as opposed to jumping over to Google and asking questions and digging through stuff. Try to do that. That's what I mean by guess. You don't have to guess completely from scratch. You have that predictive text. Right? Went to the end of the string and hit a dot, and then all the things, all the methods that go with the string popped up. And we see the return type, and what Java is really good about spelling the names out fully. So we can make a good, we can make some pretty good guesses off that information instead of just going and looking it up. So we'll grab the next character, and then we have this keyword switch for a switch case. And this is, it is, some languages it's just for syntax. Java is just cleaned up C++. So a switch is faster. And then instead of doing a big, large comparison, it's more like we're flipping a switch. We're doing it with char, which is Unicode. So we're, I guess in this case, actually flipping 16 switches at once. But it really is like, you think of it as flipping a switch as opposed to doing a big complicated comparison. We just line things up and see if that's the switch that flips whenever we have a particular set of bits. And then what do we want to switch on? We want to switch on grade in our curly braces. And then there's several cases. There's a finite number of cases that the grade could be, right? We have a case where it's an A. And which case we'll print out great job. Seems like a good message for that. I'm gonna come back and do a break. Actually, it's not gonna undo the ending. So we do have to actually type the word break. A break means step out of our structure. So there's different terms we can use. So like for a selection structure and a switch case, we can use a break, which means it's going to jump to the end of the selection structure. We're done checking our cases, so jump to the end. Otherwise, it's going to run every single one, because in this case, we really might want to check two cases, right? We might also want to check, whoops, and make sure it's not a lowercase. And for both of them, we're going to do the same thing. Whether they enter the A as an upper capital letter or a lowercase letter, we're going to say great job on that. So notice there's no break after the first case. So once it hits a case, once that's positive, it's going to run everything afterwards until it hits the break. So then no matter which case whether it's uppercase or lowercase, both of those are going to trigger to run this same line. And then we can break out of the A section. I guess same thing for B. Maybe they enter a capital B or maybe they enter a lowercase b. And if either one is triggered, it's just going to start running every line until it hits the break command. So you can categorize things like you might not always want to put the cases in a nice order like we're doing here. It might make more sense to do like vowels and then everything else. You need all the letters in the alphabet, or set up move your numbers out of order in the way that makes the most sense. The things are likely to happen together. But once a case, or once that switch is flipped, it's flipped, it's on. So every instruction is going to run until it hits the break command and jumps all the way down to the closing curly brace. I guess then we need some other ones. Not bad. Well done. Step down from that, and then our other cases, case C, capital C, case lowercase c, because either one's going to do the same thing. I guess that's not bad. And if anybody has noticed that I stopped putting the break statement in, that was to actually show you all that it keeps running. I'm going to demonstrate it. I like to see the error messages instead of just tell you about them. That way we can see them and talk about how to fix them. Lowercase d, S out, needs improvement. It's technically passing. F. Actually, there's only one left as far as our grades. So at the end, we have default. So if none of the other cases work, the one to fall back on. Kind of like the else block in a big if structure. When we get to that last one, that's our fallbacks. Like, okay, if it wasn't any of that, just do this instead. As out, that's a problem. Like good words to put there. And I left the breaks out there just to show this. So when we run that, any questions about that before I hit run?
Yes.
What's that?
When I got to the B,
Uh-huh.
the break, I ran it, and it's the great job from the case A.
Uh-huh.
Still printed with whatever message I had for case B. How do you, if you type in a B, how do you only make it say the system.out for that specific case?
Did you put a break on case A?
Oh, no, I have it on B.
Oh, so it's going to run until it hits that break. That's what I was getting ready to show here. So if I hit run, we have to get past the whole number part. So we'll say 3, and then it says enter a grade. So I notice, Danny, I have the break on case A. So when I hit A, it prints out that message and then leaves. So I run that again and jump past that part, and then enter grade. If I put B, I didn't put any more breaks in there. So once that's on, the switch is on. So it should run all of these lines. Oops, get all of them that way. So you want to make sure and put the break in there. And that's how you spot, that's how you spot the very common problem of forgetting to type break somewhere, is if you get a whole bunch of responses from your switch case. It's a personal choice, whichever one. You can do the same thing with if-else structures if you like typing that way. For those interested in game development, that is a spot where we definitely worry about speed still. So if you're heading towards game development, a switch case is fast. So it's good to use switch cases in the languages where they're faster. Because some languages we just have the syntax because it's convenient. It's a nice, concise syntax. But now with all those break statements in there, when I run it, if I enter some number there, let's say a C, we only get the one message. That working now? That's the way we have to make choices. Just a couple simple tools, but we can keep building things up from there. I'll put this other one in as a comment. It's about time for a break, and y'all know what to do on these. I'll do a multi-line comment. Notice that it automatically kind of, when I put that opening for the multi-line comment / asterisk, it left a space and put another one. Personally, I like to kind of line those up. I like things to line up a little bit better. So that closing one, I move over and then put an asterisk on every line, one space over, and that way there's a nice little straight line, and it's like a margin. That's a very, very common thing. It makes your code look a lot better. Makes your comments look a lot better. So and is going to be 2 ampersands, or is going to be 2 pipe symbols, and not is an exclamation mark. Well, just listing those out be enough for everybody. Y'all know what to do with ands and ors. And you do have to spell it out, just like you do in every other language. You can't combine conditions. You can't say X is less than 5 and bigger than 7. You have to say X is less than 5 and X is bigger than 7. That would never work. X is bigger, less than 5, or X is bigger than 7. Let me throw out a condition that actually makes sense there, that would eventually run at some point. Because if you wanted that thing that would never run unless like the computer was bugging out really bad and you were checking to see if the computer was bugging out really bad, you would probably just type if false, put false as that condition, which we wouldn't do here, but we do that in loops. Usually not if false, like something like, we'll set a Boolean exit equals false, and then we'll say while exit or while not exit, so it's not false, so that loop's just going to run forever. You don't want to be subtle if, like in that case, we're going to talk about that after the break. If what you're looking for is an infinite loop, you don't want to be subtle about it. Just directly write the word true or false there. That way, anybody looks at your code, they can see it. I guess we also have Bitwise. Bitwise and is 1 ampersand. Same thing with or, Bitwise or is 1 pipe symbol. Bitwise XOR is the caret, which it is just a coincidence that a bitwise XOR will give us the same thing as exponents. So you have 2 integers that work for an exponent. There's a more formally correct way to do that. Over the years, some versions of the Java compiler have said don't do that directly. They'll tell you it's an error. But there is that coincidence that in binary, 2 integers XORed together will give you the same thing as the integer raised to that power, which is just a coincidence, but it's a useful coincidence to have. That's short. That's much shorter to type than the formal way to do it. It actually stands for XOR, which there's not a non-bitwise XOR. We do have the difference between them. I almost never do in regular software development, like kind of like we're talking about in this class. I use it all the time on microcontrollers. But and if we had 2, I'm going to write 4-bit numbers up here just because it's So if we had two 4-bit numbers, 0, 0, 1, 0, and we said and, our regular and, that gives us 1 bit, says it's false. The result's a 1 bit false. But if we do bitwise, we'll get 4 bits back. So our first bit, 0 and 0 is 0. 1 and 1 would be a 1. The rest of those are going to be zeros. So they're an and up there. So with regular and, we get the 1 bit solution. With the bitwise, we get as many bits back as we put in. Almost never, I don't think I've ever used that on software like we're probably thinking about in this class. In with microcontrollers, actually programming them with port manipulation, where the code is like go to register 85 and put a 1 in slot 3, and then go to register 27 and put a 0 in slot 7. There I use bitwise all the time. But for regular software, I've never used it, but it's included in every language. I want to mention. We're mostly going to do use it in conditions. Right? If X is smaller than 5 or X is bigger than 7, and we want that 1 bit true or false. So we use the regular one, but bitwise will give us 4 bits back. Which actually this would count as true. So if you haven't seen it before, computers don't actually check true and false. Computers check false and everything else. And that's not false. False is 0. That bitwise and did not return false. So that's going to be not false. It's not what we would think of as true, but it's definitely not false, and the computer's only checking false. So that's part of the reason I avoid bitwise in regular software. Usually we want the 2 simples, and then there's not a non-bitwise XOR. XOR is exclusive OR, if you haven't seen that before. One or the other, but not both. 0, 1 or 1, 0, they're opposite, so they're exclusively OR. But 0, 0, 1, 1, those are the same. Even though 1, 1 would trigger a regular OR gate, there is some, we use true and false, there is some truth there. They're both true, so they're not exclusively OR. XOR can be really, really useful for checking one or the other. And there's not a non-bitwise one. So I'll just put those there, and I believe everybody knows what to do with ands and ors and nots, right? Oh, and for the not, it's a lot better to wrap things in parentheses. We can nest parentheses, wrap things in parentheses, and put the not in front of it. I was going to jump to break, but maybe one more quick thing. Show Boolean equals show. Boolean show equals, let's say, true. Where we have our selection structure, user number less than 5, that's returning a Boolean, right? It's an expression the computer's going to evaluate and return a Boolean. So what we really put in the parentheses is a Boolean. So you can do just put your Boolean here, which you could do as a thing. So if x less than 5, you put your condition there, and then you have a nice 1-word thing. Oops, I'm going to write, that's equivalent to writing true or something. That was just for an example. So we can put that condition to a word to help our code be more self-documenting, and then just check that. So like if show, is out, I don't know, it shows, or else is out, can't see it. That one almost slipped my mind, so kind of throwing it in at the last minute, but we can set what we're really checking is a Boolean. So you can store your condition to a variable and then use that variable name to have code that's a little easier to follow as far as reading through it in English. Or if you just have a Boolean, you can just use that directly. I guess I have to get up to that part. D, there we go. So you can see that condition ran. Or if we directly type false in there, which in a real situation, you probably wouldn't directly type true and false. You would do things that would result in true and false and store them in that variable. 6, enter grade C, and then get the else block there. So that's what we're really putting in there. And if you have a Boolean, you don't need to do something special. You don't have to say like if show equal true, because it already holds the value true. And doing that can make your code look a whole lot cleaner, more self-documented. Right? If we have a meaningful word there, it's very obvious to look at it and tell what it is instead of having to figure out what that condition is referring to. Any questions on selection structures? Okay, that been longer than I meant for it to. 10 minutes sound good to everybody? I see head nods in here. I assume it's okay on the Zoom call as well. So my laptop says it's 7:23, so we'll get back to it at 7:33, and I'll make sure there's plenty of time to do stuff. So it'll be fairly short after the break. I meant to go to break about 10 minutes ago, but went a little over. Sorry about that. So we'll get back here in about 10 minutes. And I'm gonna go get some coffee. I'm in my office. Stop recording.